Yeah, good morning. So I'm audible.
Good morning, sir.
Sir, good morning, sir.
Yeah,
Good morning, sir.
morning. So you can see my screen, right?
Yes, sir.
Yes, sir.
Yeah, sir.
Yeah. So this is where we stopped yesterday. So we discussed about the min terms and max terms. Okay. So min terms. What is min term? So what is a min term and what is a max term?
Midterm is under operation.
Is under operation of the input variables. The under operation of the possible input variable combinations, right? So we'll perform under operation of the what are the possible inputs there. So we'll perform under operation of those inputs there. Okay. So and the max term is or operation of the possible input combinations. Okay. Uh, Max term is an or operation of the possible input combinations. Okay. And coming to this, we'll be having sum of products. So where sum of products is nothing but summation of the min terms. So whose output is equal to 1. Okay. So whose output are equal to 1. Okay. So they'll be contributing say one output for the given output function there. So you can see the truth table here. So ABC, it's a F here. So F is a function. So here the min terms M1, M4, M5, M6, and M7. So we'll do the summation of all this. So which is called as the sum of the products. Okay. And this will contribute to a one for this function F here. Okay. And coming to the max terms, so we have to check for zeros. So whatever the remaining terms, leftover terms are called as the max terms. Okay. So remaining leftover terms are called as the max terms here. So I can write this as so pi of, I can write this as pi of, so what are the remaining terms here? So it is equal to 0 and 2 and 3. Okay. This is how we can identify the min terms and max terms here. Okay. So when for a given function. So this is one of the method here. So when the function is given is f is equal to a plus b bar c. Okay. F is equal to a plus b bar c. And for this given function, so I have to express this Boolean function as sum of min terms. So this is one of the method using the truth table. So we'll follow the another method. Okay. So where it is equation based. So f is equal to a plus b bar c. Okay, so f is equal to a plus b bar c. So this can be written like this. So actually, what we have to do, we have to convert this into canonical form. So canonical form in the sense each and every term should be expressed in terms of all the variables here. So what are the variables available here? The variables available are a, b, c. Okay. So we are what we have to do, we have to express each and every term, each and every literal in a canonical form. So canonical form is nothing but each and every literal is containing each and every variable is available in normal form or complement form here. Okay. So what are three variables available here? So a, b, c are the three variables available. So we have a plus b bar c. So in the first one, so b, c are missing, and second one a is missing. So each and every term, each and every literal should be available in the expression here. Okay. So expression lo prati okkappudu if I want to identify the min term, so I have to identify the min term. So by knowing with a I can't identify the min term. So what is the value of a? So a is equal to 1. So I have to know the values of b, c also, whether it is normal form or the complement form. I have to know the values of b and c also. Okay. In a similar way, I don't have a here. So this is called as b is 0 and c is 1. What is the value of a? So we have to find out that. Okay. So I have to convert this. This is called as a standard form here. This f is equal to a plus b bar c is a standard form. We have to convert that into a canonical form in the following method. Okay. So what is a plus a bar? So what is a plus a bar? Or b plus b bar or c?
1, sir.
Yeah. So a plus a bar is equal to 1 and b plus b bar is equal to 1. C plus c bar is equal to 1. So if I multiply this a with b plus b bar, so it doesn't make a difference. So if I multiply this a into 1, okay, so a into 1 and 1 can be written as b plus b bar. So that way I can write it as ab plus, so ab bar. Okay. So this is ab plus ab bar. So this is not this is same, which is equal to a. In a similar way, so what I can do, so ab plus AB bar, okay, so into 1. So what I'll do, I'll multiply again with a 1. Okay, so that can be written as into C plus C bar, because C plus C bar is also equal to 1. So I'll get expression like this. So AB C plus AB C bar plus AB bar C plus AB bar C bar. Right? Here. So this is how we have to convert into a canonical form here. So first term is okay. First term is converted. The first term what I got is, so A is converted into this value. Okay. So A is converted like this. So I am getting each and every term there. Okay. So I am getting each and every term. So A is converted like this. And coming to B and C bar here. So B bar C. So B bar C can be written as this, like we can write this as B bar C into
A plus A bar.
Yeah. So the missing term is A and A bar here. So B bar C into A plus A bar. So that is equal to, so A B bar C plus A bar B bar C. Okay. And I will write them in the final expression. So F is equal to, so A is replaced with this value plus B bar C is replaced with this value. Okay. So A is replaced with this value and B bar C is replaced with this value. Okay. So we have 2AB bar C. So express X is equal to X. So we can remove one of them. Okay. So we have ABC plus ABC bar plus we have AB bar C and AB bar C. We have two times. I'll write it as one time here. AB bar C plus AB bar C bar plus A bar B bar C. Okay, and this is we have to express this in the terms of min terms here. Okay, so we have to express them in terms of the min terms here. So we have to check what are the min terms available here. So A B bar C. So what happens here for A B bar C? So ABC is, what is ABC? ABC is M7, small M7. Okay, and A B bar C. So what I have to write here? So A bar term. This is one is a normal term. This is A is 1, B is 1, and C is 1. Okay, and here A is 1, okay, A is 1, so B is also 1, and C is equal to 0. A is 1, B is 0, and C is 1. And in case of min terms, so the complement term is 0 and normal term is 1, is equated to 1. So 1, 0, 0, and this is 0, 0, 1. If I write it in a order, like from ascending order, like 0, 0, 1 is called as M1. Okay, and other things available. So M4 100 plus M5 101 plus M6 110 plus M7. Okay, so there's a sum of min terms here. So that what I can write this as f of ABC, because these are the variables here, is equal to capital ABC, right? So A comma B comma C is equal to sigma of sigma of 14567. Okay, sigma of 14567. Okay, so here we missed 6. Yeah. Okay, so this is the other way here. So one is, so if I want to find the minterms, if you are said to find the minterms, so just if this is a question, simple question, just write the two tables, substitute those values and find the minterms here. Okay, and the other way is like find the canonical form. So after finding the canonical form, okay, so you can understand this. So if I get a canonical equation here, whereas each term you can see here, so each term is containing all the input variables. So that is ABC in normal form or the complement form. So then only we can find the minterms here. So M1 plus M4 plus M5 plus M6 plus M7 here. So clear?
Yes, sir.
Yes, sir.
Okay. Next we'll see the same problem, but we'll see it for max terms. Okay, so we'll see it for the max terms here. So max terms will take the problem, and so this is one of the way to find the max terms, but you'll be asked the questions like this. Express the Boolean function as product of max terms. Okay, so we'll take another problem. So you're clear with this, it's everyone. So be clear with these concepts. Okay, so you may feel that I'll listen afterwards and I'll understand, but it's not possible. Just listen to it carefully. Right, and the next one, so take the next problem. Express the following Boolean function. So f is equal to xy plus x bar z as product of max terms. Okay, so product of max terms in the sense I need the OR operation of the input variable. So whatever the equation I gave here, so it is sum of the products only. Okay, so what I have to convert here is, so I have to find the OR operation of the input variables. So using some Boolean functions or Boolean laws. Okay, so what I can do, I can convert this as a product of max terms. So product of max terms in a sense, so it should contain all the x, y, z, but all x, y should be in the addition format, like x plus y plus z or x plus y plus z bar. So this is what we have to do here. Okay, so this is sum of products term here. So if I want to go for product of max terms, just we need some simplifications here. So use some theorems to convert this given function into the product of max terms. Okay, so already we had heard about the max terms here. So max term is nothing but the OR operation of the input variables, OR operation of all the possible input variables. Okay, so those are nothing but the max terms. Okay, so we'll see here. So f is equal to this value. Okay, so I can write this as consider this as x here and this as yz. So x plus yz is equal to, so x plus y into x plus z. Okay, so this is, or consider this total term as x here and this as yz. So x plus yz is equal to x plus y into x plus z. So x plus z. Okay. So since x plus yz is equal to plus y into x plus z. So that is the formula we used here. Okay, and so that can be again written as like this. So this is x plus x bar y. So this is x here, and this is x bar, and this is y. X plus x bar y is equal to x plus y here. So x plus y is x bar plus y, and we have x plus yz. So again the same formula. So this is x and this is yz here. So x plus yz is equal to x plus, sorry. So the z is x here. So x plus y into x plus z. So again this sorry. Okay. So sorry. So this is x plus x bar y. It is x bar plus y. That's fine. See any mistake there? Yeah. Okay. So this is x bar y plus x plus z plus y. So that is equal to bar y x plus z and y plus z. Okay, so can I express this equation as a product of max terms, because you know this is the product term only. So I mean this is this one product term. I mean product of max terms here. I mean product of sums here. So this is first sum, this is second sum, and this is the third sum. In each sum we are missing with one variable here. So xy is there is no z here, and here xz is there, and here yz is there is no x here. Okay, so earlier what we have done, here is like, so we had multiplied them with 1. So a unte a into 1. So where 1 is written as a plus a bar. Okay, and again what we'll be doing here is, so here it is a sum term. So if it is a product term, so what we'll be doing here is, so we'll be multiplying. So sum of products sum will be multiplying with 1, because it is a multiplicative identity. So a into 1 will not change the result. So 1 can be written as a plus a bar. Okay, so multiplicative identity is 1. So hence 1 doesn't make a difference. So here in case of plus here, 0 doesn't make any difference. Okay, 0 doesn't make any difference. So 0 is the additive identity. So hence add a 0 to the each and every variable available here. Okay, so what I can say here is, so add 0 to each and every variable. Okay, so actually this is the simplified version. So what I have to do here is, I have to convert them into canonical product of sums. So add 0. So add 0 and 0. Okay, so 0 is nothing but I can write 0 as, so in the first case I can write 0 as x bar the first case I can write 0 as, so xy only z లేదు కాబట్టి I can write 0 as z into z bar, because z into z bar is equal to 0. Okay, the similar way I can write this as y into y bar. Okay, 0 is replaced with these values, and I can write it as x into x bar. Okay, getting my point. So I had to convert this into product of max terms here. Okay, so product of the max terms. So what I can do here is just insert a 0 to each every sum term here. So product of sums here. So for each sum add a 0, because adding a 0 to each sum doesn't make any difference. In a similar way, adding a 1 to the each product doesn't make any difference. Okay. But what my aim is to convert them into the canonical forms here. So each expression, each sum should have each and every variable. In a similar way, the earlier case, so each product should have each and every input variable that is available here. So then only we can identify the min terms and max terms here. Okay, so x plus. So this can be written as. So what I can write here? So it is x plus y plus z bar. So what is this? So this can be written as this is x here, and this is yz. X plus yz is equal to x plus y into x plus z. Getting my point here? Consider this as x here. Okay. Consider this as x and this as y. Okay. So this is x plus yz. Okay. X plus yz. This is y. Okay. And this is z. So this z bar is considered as z here. Okay, so this is x here. So red color is around the x and term only, and this is y here, and this is z here. So what is the formula for x plus yz? It is x plus y. Okay, so x plus y into x plus z. So that is x bar plus y is x here. Okay, x plus y. So y is z here plus y into x plus z. So x is plus okay. So this is the formula here. Right, so x plus y into x plus z. So this is what we got a standard product form here. I mean canonical product form. The similar way. So all these terms, this is treated as x here, and this is yz, and this is treated as x here. This is yz. Okay, so what I can get here? So x plus z plus y into x plus z plus y bar. Okay, similar way. So y plus z plus x and z plus x bar. Okay, so this is the final term here. So the final canonical form of the term here, and I have to find. So what are the max terms from this one? So max terms I'll find out yes sir. In case of max terms, so normal form is equal to. So complement అయితే 1 అని. Okay, so normal form అయితే 0 అని. Okay, so here what we got here. This is complement form. So complement form కాబట్టి 1. So normal form is 0. Okay, and again normal form 0, and here it is 1 0 1, and here it is 0 0 0, and here it is 0 0 1, 0. Again, we have express y plus z 2 times. I can take it as 1 time here. So I'll remove this x plus y plus z. Okay, and here it is 0, 0, 1. Okay,
1.
what are the terms here? This is 4, 5, 0. Sorry, this is 4. So 100, it's 4. So 101, it's 5. So triple zero, it's 0. And 001, 1. Okay, and 0. Sorry. So this is we have to rearrange them. So x, y, z should be rearranged. So x, y, z. So for this is 0. So rearrange them. This is x, y bar, z. And this is x bar, y, z. So rearrange them so that you can understand what is the max term here. Okay. So one is 1, 0, 0. Okay. So and so remove that also. So we are left with 4 terms here. So this is 0, 1, 0. Okay. So 0, 1, 0 is 2, 0, 5, 4. So the max terms are so m0 into so m2 into m4 into m5. So this is the product of max terms. So I can write this as f of xyz, because xyz are the input variables, is equal to pi of so pi of 0 to 4, 5. Clear?
Yes, sir.
Okay, so any doubts, let me know, because these concepts are very important. So tell me fast, any doubts?
No, sir.
Yeah. Okay, so this is a product of maxims. How to express product of maxims? So product of maxims so we should be adding 0 to the any sum. So where there is a missing term. Okay, so we'll be having sums here. So we'll be doing product of the sums here. So when we are doing the product of the sums, so each sum should have each and every variable in normal form or complement form in case of the canonical representation of product of sums, which is called as POS. Okay, so if there is if any kind of variable is missing, just add a 0 to that variable. So because 0 is nothing but z bar or y bar or x bar. Okay, add 0 to that variable. Okay, because adding a 0 doesn't make any difference to the sum. In case of products, so multiplying with 1 will be done if there is any missing variable. Okay, so and 1 is written as 1 can be written as a plus a bar and b plus b bar and c plus c bar or d plus d bar, whatever. Okay, and multiplying with 1 to a given product doesn't make any difference. Okay, hence we are adding zeros and ones here. And what is the main intention here is to convert them into the canonical forms, where canonical form is finding each and every each and every product or each and every sum will be having each and every literal in normal form or the complement form. Okay, clear?
Yes, sir.
Yes, sir.
And
Yes, sir.
if you are given an equation and you are asked to draw the logic diagram. Okay, so draw the logic diagram, and if you are given a equation like this, so y bar, so you'll be given some standard form. So standard form is So we may have missing terms also. So there is no need of having all the terms. So you can have missing variables also. So implement this function using logic gates, or else draw the logic diagram. Okay. So first of all, identify how many number of products are there and how many number of sums are there here. Okay. So what is this equation is called? It is the sum of the products here. Sum of the products. Okay. So we have to identify the product terms here. This is one product term, this is one product term, and this is another product term. So I bar is also called as a product term here, because or else I will take it as a single input here. Okay. So totally we'll be having two product terms, xy, or else if I take it as xy bar. Okay. So if I take it as x bar, y bar, x by bar, either what is to know. Okay. We'll be having three product terms. Okay. So how to implement the product terms using logic gates? So how to implement the product terms using logic gates? So how to implement product terms using which logic gate we have to implement the product term?
OR gate, sir.
OR gate.
OR gate, a product term.
AND gate.
AND gate.
Multiplication is done with help of, so which logic gate?
AND gate, sir.
AND gate. So AND gate is for
AND gate, sir.
dot operation and OR gate is for plus operation. Okay. So what we are doing here is we'll be having three product terms and all the product terms are added here. All the product terms are added. So what we'll be doing here is, so three product terms are there and three product terms are added with a single OR gate. All these three outputs from the three AND gates, so will be given to a single OR gate. Okay, I'll be drawing the diagram. So don't go for perfection. Okay, and you can check here. This is one product term. This is the second product term, and this is the third product term. So all these three are added here. Okay, so product terms are multiplied with OR gate. Sorry, AND gate. This is one AND gate, second AND gate, third AND gate. So these are three product terms, and all these product terms are added with the OR gate. So these three are given to an OR gate. So this is F, and first product term it is x bar, y bar as inputs of x bar and y bar, and second product term we have xy, and third we have, sorry, so x bar, and this is y, and this is z bar. Clear?
Yes, sir.
So this is some of the products. We had to use AND gate to implement the products here, and for addition we'll be using only one OR gate. So some of the products అయితే ఒక OR gate చాలు. So మీరు ఎన్ని AND gates, ఎన్ని product terms ఉన్నా last లో ఒక OR gate ఉంటే చాలు. So in case of the some of the products. And coming
Okay,
to
sir.
the product of sums. So product of sums అయితే will be using only one AND gate and multiple OR gates. So if there are multiple sums, we'll be using multiple OR gates, but totally we'll be having only one AND gate in case of the product of sums. Okay, so we'll see that. So taking the logic diagram, right? So earlier one. Okay, so now express this as so f is equal to, so x into y bar plus z and X bar plus Y plus Z bar. So this is product of sums here. Okay, so product of sums. So for product of sums, so we'll be having two sums here. Two AND gates are used here. Okay, two OR gates are used because sums are implemented with OR gates here. And total will be having a multiplication of all these three. So we'll be using one AND gate. We'll be using one AND gate. Okay, so diagram will be like this. Okay, so we'll be having two product terms. So the product terms are implemented with OR gates. It's one OR gate. And we have one input, single input. So single input key, there is no need of OR gate here. So totally three outputs, three product outputs will contribute. I mean, we are given to the one AND gate. So what this AND gate will do? So it will multiply all these sums here. Okay, so it will multiply all this sums. So this is X here. This is Y bar Z. So Y bar plus Z here. So which is given to OR gate. And this is three outputs. So X bar. So Y Z bar. So product of sums are implemented with the sums are implemented with OR gates, and finally we have to do the product here. So we'll be using one AND gate for the product of sums. Okay, so maybe ask a question like this: so many AND gates and OR gates are used in this for this expression? So many AND gates and OR gates are used for this expression. So sum terms even nice. So sum terms we have two sum terms here. So two sum terms we'll be using two OR gates. Okay, and so all of them is a product. Some of the product of sums here. So for a product of sums, we'll be using only one AND gate here to perform the multiplication of all the sums here. In a similar way, product of sums. Clear?
Yes, sir.
Okay. So take 5 minutes break. So we'll be back. So we'll discuss the problems related to this min terms and max terms. We'll see 3 or 4 problems. Okay. So related to this max terms and min terms. Okay. So understand these concepts. So we'll see them. Okay. So take 5 minutes break. I'll be back. The class is still 12:30. You have to be patient. I'll be giving short breaks for half an hour to 45 minutes. Right. But be patient. Yeah. Right. Everyone there? So we'll see these kind of problems. So we'll see the same kind of problems. So because you'll understand. So when we solve more and more problems, so you'll get familiar with those kind of problems. So you'll be able to solve more and more problems here. Okay. So we'll see the next one. So express the following Boolean function. Express the following Boolean functions as a sum of min terms and a product of max terms. Okay, so this is the problem here. Express the following Boolean function as sum of min terms and product of max terms. So the function is B bar D plus A bar D plus BD. Okay, so express this term. So what we have to do here is we have how many terms here are missing here? So many terms are missing here. So the function is like we have all the terms like A, B, and D. So there is no C here. Okay, so only ABD terms here. F of ABD. We have to check the values of ABD here. Okay, so F is a Boolean function of the variables A, B, D. So if there is C as an uninter, we could have taken C, but there is no C here. So only the function is Boolean function of this Boolean function is containing the variables A, B, and D here. Okay, so what I had to do, I had to in the first one A is missing, and second one B is missing, and the third one again A is missing. Okay, so what I had to do, so I had to multiply this with 1. Each and every term is multiplied with 1. Okay, so each and every term is multiplied with 1. So B bar D into 1. So plus A bar D into 1 plus BD into 1. Okay, so missing terms should be replaced here. So B bar D into 1 is A is missing here. So it is A plus A bar. Okay, so plus A bar D into 1, that can be written as B is missing here. So B plus B bar. Okay, and BD into A plus A bar. Right, and the values are like A, B bar D plus A bar B bar D plus A bar BD plus A bar B bar D plus ABD plus A bar ABD plus A bar BD. So check the terms here. Any repeated terms? Any repeated terms here? So A B bar D and A B bar D. So actually you can see here there is one repeated term A B bar D, and this is also A B bar D. So x plus x is equal to x in case of Boolean algebra. Okay, hence we can write only 1x here.
Sir, A bar PD also, sir.
Yeah, A bar BD. So these terms are repeated here. So x plus x is equal to x here. So I can write only one term here. So A B bar D plus A bar B bar D plus A bar BD, okay, and ABD. Okay, so then A bar BD. So this is the terms here. These are the min terms. So that is available here. So that is so min terms are nothing but. So what is the first one here? So this is 111 and this is 101. So 101 ante. So 101 is M5 plus 001 is M1. Okay, and this is A bar BD. A bar ante 0. So B ante 1 and D ante 1. So 011 is M3 and ABD is 111, that is M7. So these are the min terms here. And what are the max terms? Max terms are nothing but the remaining terms are the max terms here. Okay, that is capital M0. Okay, so capital M0, M2, M4, M6. Okay, so these are the sum of min terms and this is the product of max terms here. Okay, I can write this as sigma of so 1 comma 3 comma 5 comma 7, and this is equal to so pi of 0 to 46. Okay, so if we are given like this, just find the min terms, you can find the max terms. When you know the min terms, we'll find the max terms. Okay, so that is the expression here. So take another problem like this. So express the following Boolean function as sum of min terms and product of max terms. But కొంచెం difference ఉంది ఇక్కడ. So ఇక్కడ ఏంటంటే express the following Boolean function as sum of min terms and product of max terms ఇచ్చి. So the problem is given like this. So B bar means, so what I assume is, I'll assume only there are three input variables available here. So I'll be taking only as ABD here. So if the problem is given like this, okay, if the same problem is given like this, so f of A comma B comma C comma D. So here we have to consider all the four input variables. So here AC is missing, and here BC is missing, and here AC is missing. So these terms should be added to this each and every term here. Okay, so express the following Boolean function as sum of min terms and product of max terms. So do the problem and tell me the min terms and max terms. So problem again, and tell me the final answer. Okay, the simplified one. So what I can write here is, so there is A term missing. So write as A plus A bar, the first expression, and we have B term. So write as B bar as it is, and C term is missing. C plus C bar. Right. In the same way, so A term is there, B term is missing. So write as B plus B bar. So don't get confused. So simplify each and every term. So simplify each and every term, so you'll understand it. So C plus C bar into D plus so there is no A term here. So A plus A bar, and we have B term, fine, and we have, there is no C term here. So C plus C bar
C plus C bar.
into B. Okay. So simplify each and every one. So first go with
Sir, C
Emma.
bar.
Sorry. C plus C bar. So simplify this one. Afterwards simplify this one and simplify this one. And repeated terms you have done thesis saying and tell me the final sum of the products and product of sums. So what I need is f of ABCD is equal to sigma of A lo kavalna. Faster. Just a simple simplification. It should be faster, right? So you should have a codes from will be this is ABCD, right? So we should know the BCD code from 0002 to 1111. So 15 mark course second manaku. The midterms will be from 8421 codes. So from the 8421 codes, know what is that midterm. Done. So I'll not see chat box. I don't know whether you responded in chat box or not. You should not take much time. In case అవి రిపీట్ అయినా కూడా పెట్టండి కావాల్సి ఉంటే మిన్ టర్మ్స్ చేసిన తర్వాత కావాలంటే you can eliminate that. You can remove that. Hima? So make it fast.
Sir,
M1,
M1,
fine.
M1, M6, M7, M11, sir.
One minute, 1 minute. So M1, okay.
Plus M6.
No. So we get total of 1, 2, 3, 5, 7, 9, 11, 13, 15. So we got only few. Lost with the simplification.
Okay, sir.
Yeah, check one more time. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . This is matter of multiplication. So just what I have to do. So if I check with this, so is equal to. So I'll do with this like so A.
Sir, 11, 9.
Yeah, 11, 9.
3, 1.
11, 1 minute, 1 minute. 7,
9,
uh,
3,
3,
1,
okay.
7,
1, M7, okay.
5,
M5, okay.
15, 13.
M15, M30, okay. So 1, 2, 3 is there. I mean, we are writing it in order. So we are missed with 2. 2 would be saying 1, 2, 3. 2 is missing. So 1, 3, 5, 7, 9, 11, 13, 15. So only 2 is missing. Remaining all are there. Check for 2. Because there's a lengthier one, we'll definitely work on it. Because this is the answer. Okay, yes. Okay, so write it in order. M1 plus M2 M3 plus M5 plus 5 M7 plus M9 M11 13 plus M. Okay, so these are all the min terms here. So what are the max terms? The min terms are max terms. Max terms are capital M. M0 dot M4 dot M8 dot M10. The remaining terms are the maxims. M12. To do the simplifications properly, we'll definitely get this. Okay, so I understood the concept, I think, but I can't do all the simplification. This is assignment problem, so we ending. Okay, so just you go with step by step. Don't do all the things in a hurry, worry. Okay, so first, okay, afterwards, what is this answer here? So A B bar, so A B bar plus A bar B bar. So afterward, what I have to do? So we have the C term there. Okay, so we have the C term to multiply with. So there's no C term, so multiply with. C and C bar. Okay, so that will get it as C bar. Please mute. There is a disturbance from someone, so please mute your mic. So A B bar C bar. Okay, plus A bar B bar C plus A bar B bar C bar. Okay, only D term is missing there. So multiply with this D term into D here. So each and every term will be having D. So here also D, here also D, and here also D. So if you get confused, just write the midterms for all this. Okay, so midterm famous time ikkada. So this is 1011. So 1011 8421. So 8421 ante 8 4 ledu 21. So 8 9 10 11. So this is M11. So repeated undevanni raayadante. So this is M11 plus So what is this 1001? So 1001 is M9. Okay, and 0011 M3 and 0001 M1. So this is for the first term. So E term. Okay. So next term. So do it in a systematic way. So ఏవైతే రిపీటెడ్ ఉన్నాయో వాటిని ఎలిమినేట్ చేయండి అంతే. Okay. So do it in a systematic way. The second term. So what is the second term here? So A bar D. So A bar D ni ela రాయించుకున్నాం. So there is no B term and there is no C term. Okay. So first do this. So that is equal to A bar B plus A bar B bar. Okay. So that is done. And next C plus C bar. Multiply this with C plus C bar. So that is equal to A bar B C plus A bar B C bar plus A bar B bar C plus A bar B bar C bar. Okay, and we have D. So multiply with D here. So insert D for all the terms here. So D, D and D. So what are these terms here? So 0, 1, 1, 1. So that is M7. M7 plus. So you know where I'm taking zeros. I mean, ikkada check cheyali meer. This is complement is a zero term. Okay, and this is 1 and this is 0 and this is 1. So 0, 1, 0, 1. So this is M5. Yes, and this is a 0, 0, 1, 1. 0, 0, 1, 1. So M3 plus 0, 0, 0, 1. So it is M1. So what are the repeated terms here? So M3 and M1 are repeated here. Okay, so M1 and M3 are repeated. And go for the next one. So do the next one. This is BD. So BD can be written as BD is written as okay, and the first one is this one is equal to AB plus so A bar B. So this multiply with C and C bar. So that is ABC plus ABC bar plus A bar BC plus AB A bar BC bar. Okay, so we have D. So include D for each and every one. Multiply this with D. Okay, so what is the values I'll get here? So ABCD is 15. So, that is 8421. That is M15 plus so 1101. So 1184. Right? 84 is 12. That is 13. Okay, and here you can check. This is 0111. This is M7. Plus this is 0101. This is M5. Okay, so what are things repeated here? So M5 is repeated, M7 is repeated, 15, 13 will be there, and here also M1 is repeated, M3 is repeated. So what are the terms here? I think there is no 2, right? So one of the persons told, but there's a mistake, I think, here. So we get a 2 here. So anyways, 0, 0, 1, 1, 1, sorry, there is no 2. Okay, so these are the terms here. So the terms are, sorry, I don't know that person name. So you are correct. He is not showing correct here. So it is M1 plus M3 plus M5 plus M7 plus M9 plus M11 plus M13 plus M15. Okay, so these are the min terms. So 1, 3, 5, 7, 9, 11, 13, 15. Okay, so max terms are the remaining terms 0, 0, 2, 4, 6, 8, 10, 11, sorry, 10, 12, 14. And max terms are is equal to remaining terms. There is no 2 here. And add a 2 here. Clear? So these are the min terms and these are the max terms. Yes or no?
Yes, sir.
Okay, fine. So this is how we have to find the min terms and max terms. Okay, and we'll do one problem related to max terms. Take on this problem, so obtain the this expression. Okay, so f is equal to xy plus z, y plus xz. So what I have to obtain here? So canonical product of sum. So canonical in the sense each and every term should be the product term, and each and every product term should contain all the literals. So what are the literals here? XYZ. So XYZ ప్రతి ఒక్క దాంట్లో ప్రతి ఒక్క సమ్ లో XYZ ఉండాలి. నార్మల్ ఫామ్ లో అవ్వచ్చు, కాంప్లిమెంట్ ఫామ్ లో అవ్వచ్చు. Okay, so xy plus z and y plus xz here. So using this distributive law, x plus yz is equal to x plus y into x plus z. Okay, so this is x plus y into, sorry, x plus y. So this is considered as x here, and this is yz here. So that is z plus x into z plus y. In a similar way, this is x plus yz, this is x and this is yz here. So x plus yz is equal to x plus y into, so y plus x into y plus z. Okay, so this is the term available here. So I can rewrite like this here. So x plus y, and the second term is x plus z, y plus. So we have 2 y plus z here. So I can write only 1 plus y plus z here. So y plus z and y plus z. Yeah, 2y plus z. I can write it as 1y plus z. Okay. So and each and every term, what is missing? In each and every term, so you can see here. So first some term, so x is missing. What I can write plus 0. I can write plus 0 plus 0. Because this is product of sums, we have to add a 0. And here is x plus y plus 0 is nothing but z into z bar because z is missing there. And x plus z plus 0. 0 is nothing but y into y bar because y term is missing. And y plus z plus 0, x term is missing. I'll write it as x bar. Okay. And here x plus y z z bar. So here I can consider this as this is x here and this is yz. So x plus y into x plus z. So it is x plus y plus z and x plus y plus z bar. Okay, in a similar way, the second one x plus z plus y, and here it is x plus y plus x plus z plus y bar, y plus z plus x. Y plus z plus x bar. Any repeated terms? X, Y, Z is a repeated term. So that is equal to x plus y plus z. So into x plus y plus z bar into x plus y bar plus z and x bar y. Plus here it's a plus. Clear? So any repeated terms? So here repeated terms is I think 1, 2, 3, 4, 5, 6. We have 2 repeated terms. I think this x plus y plus z is 1 repeated term, and yeah, we have 3 repeated terms x plus y plus z. So 3 repeated terms are removed, and this is the term here. So what are the max terms here? So that is equal to, so 0 is the normal form and 1 is the complement form. So it is a normal form కాబట్టి 0 ఉంటుంది అక్కడ. So it is 0 0 0. So this is 0, x is 0, so y is 0 and that is 0. And here the next one is x is normal form. So normal form ante it's a 0, so y is a 0 and z is 1. Okay, and so what is the next term here? So it is 0 1
0.
0, and here it is 1 0 0. So the max terms are capital M naught into M1 into M2 into M4. Okay, so that is equal to pi of f is equal to pi of 0, 1, 2, 4. Okay, 0, 1, 2, 4. Clear?
Yes, sir.
Right?
Yes, sir.
So these are all the problems will be in case of midterms, max terms, it's a problems only. Okay. So if you are given the midterms and if you are given the max terms, the problems will be like this. Okay. So these are the model problems for the midterms and max terms. We have to find the sum of midterms or product of max terms and taru. Okay. Or define the product of max terms and taru. So these are the methods to implement while using this here. Okay. So take down the next problem. So next model problem. So implement the following Boolean function using logic gates. So f is equal to xy plus x bar y bar plus y bar z. Okay, so we have to draw the logic diagram for this. So how many so logic gates you implement here? So you can implement. So for multiplication, we have to use AND gates. Okay, and this is the sum of the products. So all the products can be added. So with the help of one OR gate here, and we have inverters here. I mean, we can use the inverters. So x bar and y bar. So those are used with the inverters. Okay, so you can use them as a inverter. So ఒక standard method చెప్తాను. So any logic diagram to draw చేసేకి, you find this standard method. Okay, so what are the inputs available here? So this is the standard method. 1 minute. It's a follow the standard method to draw the logic diagrams. So follow this method here. So we have the inputs x here, y, and z. Okay. So draw the straight line. So try to draw the straight line. So it's not possible for me. Okay. And this is the normal form. And you write a inverter. I mean, so give this input to a inverter. So this will be x bar. Okay. So ఇది x అవుతుంది. ఈ line అనేది x bar అవుతుంది. Okay. And again we'll be having another inverter. So this is a standard method because a circuit diagram and it'll implement చేయండి. Standard method lo we can draw the logic diagrams easily. And this is y and y bar, and the other one is z and z bar. So that's the inverter. So you don't confuse here. That is the inverter. So what we have to do here is we have to implement this sum of the products here. So what are the products available here? This is the first product and second product and third product. Okay. So we need 3 AND gates. So this is the first AND gate, and this is the second AND gate, and this is the third AND gate. And all the products are given to a, I mean, we have to add all these products here. So, and these 3 are given to OR gates, one OR gate. Okay. And we have to select the inputs for these AND gates here. So the first one is XY here. So where is X here? So this is X here. So put a cross mark there. And where is Y? Here it is Y. So these 2 are given to these 2 inputs. This is X is given, and here it is Y is given. Okay, the first on, this is the first product term here, and second product term is given to another AND gate. So what is the value here? It is x bar y bar. So x bar is, I mean, we have to take from the inversion here. So inversion of x bar is, this is x bar. Okay, so this is x bar, and this is y bar. So this is y bar here. So this is the standard method. So cross mark పెట్టినామంటే ఇక్కడ కనెక్షన్ ఉందని, మిగతా చోట cross mark పెట్టలేదంటే ఇక్కడ కనెక్షన్ లేదని. And y bar z. So this here we have y bar, and here we have z. So this is z here. Okay. So this is the standard method of drawing any logic diagram. Here, this is xy. This is x bar, y bar, and this is y bar z, and all three are added here. So all these three are added, and this will be the sum here. So f is equal to this sum here. So clear?
Yes, sir.
Yes, sir.
Okay.
Yes, ma'am.
Yeah. Okay. And next we'll see one more thing here. So diagram draw చేసుకున్నారు కదా?
Yes,
Yes,
sir.
sir. Yes, sir.
Okay. So and sometimes we'll be given some circuit diagram. You have to find this function and you have to draw the truth table. Okay. So we'll be given some logic diagram there. Okay. So I'll draw the logic diagram. So first of all, what we'll do here is, so take down this problem. So write the Boolean expression and construct the truth table describing outputs of the circuit below. Given below. Okay, so I'll be drawing a logic diagram. So what I have to do, I have to find the expression first. So you have to find a f first. So f find out చేసిన తర్వాత ఏం చేయాలి అంటే just go for the next one. So find the logic diagrams there. Okay, so we'll just go with a simple one. So I'll be having అంటే మీకు diagrams ఎలా అన్నా ఉండొచ్చు, but I told the earlier one was a standard method. So ఆ methods లో ఉన్నా పర్లేదు, లేకుంటే వేరే methods లో ఇచ్చినా మీకు ఎలా ఇచ్చినా కూడా, so you have to understand it. So this A, and I have so BCD, and I have E. Yeah. So BCD is given to 1 AND gate, and so all these three are given to so 1 OR gate. Okay, so tell me the value of f. So what is the value of f? So f is equal to addition. We have to start from back process లో start చేద్దాము. So ఇక్కడ నుంచి తీసుకోండి. It is this is a OR gate here. It is addition of so A plus BCD. This is a AND gate here. So A plus so BCD plus another sum is E here. Okay, so A plus BCD plus E. Okay, so this is how we have to find the expression for this. So we have to know the logic equation. So we have to know the equation for each and every logic gate. Okay, so this is A plus BCD plus E. So draw the truth table for this. So truth table draw చేయాలంటే ఏం చేస్తారు? So first of all, write all the inputs. Inputs are A, B, C, D, E. So if E is 5 inputs and almost 32 వస్తాయి. So I have to write it from 16, 8, 4, 2, 1 codes. So 16, 8, 4, 2, 1 codes. Okay, so up to 0, 0, 0, 0 నుంచి So where the maximum value is 11111. So 11111 is 31 here. So 32 inputs vastayi, and the output by is this one. So substitute all the values here in this equation and we'll get the value of F here. Clear? So this is how we have to follow this.
Yes, sir.
Okay. So it'll be given the diagrams like this. So based on these diagrams, first of all, obtain the Boolean expression. After obtaining the Boolean expression, draw the truth table. So truth table is lemundali ante. So we'll be having all the possible inputs, okay, and all the possible outputs. So we'll be having one output only. If the equation is F here, so we'll be having one output here. So inputs, if you are having two inputs, there are four possible input combinations. If you are having three inputs here, we'll be having 8 input combinations. If you are having 4 inputs, we'll be having 16 input combinations. If you are having 5 inputs, we'll be having 32 input combinations. Okay, and if it is like the next one, so the next level. Okay, so finding the expression is very important. Okay, so finding the expression is very important. Finding the Boolean function is very important, and afterwards the remaining things follows. Clear?
Yes, sir.
Yes, sir.
Okay, so take this assignment problem. Yeah. So take this assignment problem. So the Boolean function is given here. Function f is equal to x y bar z plus x bar y bar z plus w bar x y, and this is a little bit complex one, but I mean they're lengthier ones. They're not complex. They're lengthier ones. W x bar y and the w x y. Okay, so for this Boolean function, obtain the truth table. And the next case is to draw the logic diagram. Okay, draw the logic diagram of this one here. Okay, and so check here. So what are the inputs available? This is the standard form here. So we'll be having x, y, z only. So w. So we'll be having 4 inputs here. So if I want to obtain the truth table, so it will be like this. So w, x, y, z. Okay, so these are the 4 inputs here. And I have to find each and every term here. So what is the term I have to find here? So I have to find x y bar z bar and x bar y bar z. Okay, so find these values by substituting these values into the equation. So x w x y z, what are the possible input combinations I'll get here? So 0 0 0 0, the 0 0 0 1. So we'll be having 16 input combinations here. So 0 0. So 8421 codes of 0 0 0 to 1 1 1 1 1 1 1. Okay, and here it is 0 0 1 0. In a similar way, 0 0 1 1. So till up to we hang the values from 15. Okay, and first of all, what I need here? I need this value, I need this value, I need this value, I need this value, and I need this value. So these are the outputs here. I mean, so these are the okay, so these are the product terms here. So I need all these values and finally add all these things. I'll get the value of f. Okay. So I need these values here. Find all these values. Well, find out this and just substitute the values of x, y, z in that I mean, need to substitute here and there. So substitute these values. So a input combination here is values ni substitute cheyandi. Okay. So after which add all these things. Add all these things. I'll get the value of f here. Okay. So substitute these values. For example, for this one, so what is the value of x here? X is 0, and y bar is 0, and y bar is 1 here, and z is 0. So 0 into anything is 0. I'll get a 0 here. Okay, and here also I'll get a 0. 0, 0, and here it is a 0. So f will also be 0 because we are adding all zeros here. Okay, if any of the term is 1, the output is 1. Okay, so fill this truth table and drawing the logic diagram based on this Boolean function. So how many product terms do we have? So we have 1, 2, 3, 4, 5 product terms and only one OR gate. Okay, so 5 product terms and only one OR gate. So we can go for the standard method. I told you the standard method, right? Okay, so I'll implement a standard method here. Okay, the standard method will be like this. Okay, so we'll be having a 1, 2, 3, 4, 5 product terms. So 5 product terms, 5 AND gates. There is the expression here, and we'll be having 5 product terms. So 5 AND gates. So 2, 3, 4, and 5 AND gates for 5 product terms. All these products are given to OR gate. So all these 5 inputs are given to OR gate here. Okay, so konjam neat draw chesukondi. And what are the inputs available here? So we'll be having W, X, Y, Z. So this is the standard method of taking this, drawing the logic there. So simpler method. And this is W, W bar, X, X bar. So Y, Y bar, and Z, Z bar. Okay, and what is the first one here? X, Y bar, Z. So you konjam pine draw chesukondi, నేను కింద draw చేస్తాను. So I'll take this as W, X, Y. So where is W? This is W. And where is X here? This is X here. And where is Y? This is Y. The similar way, W, X bar, Y. W, this is X bar, and this is Y. This is Y, this is X bar, and this is W. Okay, so similar way, finish all the remaining things also. Clear?
Yes, sir.
Yes, sir.
Okay, and yeah. So I forgot to tell one more model. So these are the things So you do these things, okay, and take on the last problem of this unit. I mean, of this half part of this unit. So this is the second part what we are discussing, and we'll go for the third part. Okay, so I'll just give an intro of this third part. So then we'll see tomorrow. Okay, so simplify the expression using Boolean algebra. So this is one method. Y of A comma B comma C is equal to, so it will be given the mean terms sigma of 1357. Okay, so it will be given like this. So simplify the following simplify the following expression using Boolean algebra. So mean terms ichchintaru. So mean terms first I have to write all the mean terms. Okay. So mean terms is one is, so ABC and icharu. So one ravalante ABC lo em cheyali, it is equal to, so A bar B bar C, because this is you can check here. So one ravalante this should be 0, this should be 0, and this is 1. So 3 ante this is 0 1 1. So 5 is nothing but this is 1 0 1. 7 is, this is 1, this is 1, and this is 1. Okay, so I have to expand this. So 3 is, A is 1 and B is 0 and C is 1. Okay, and 5 is, sorry, this is 5 and 3 is 0 1 1. So that is A bar B C 0 1 1. That is 3 here. The last one is 7. So A B C. Okay. So can I simplify here? I can take A bar C as common here. A bar C as common. I'll get as B plus B bar. And also I can take AC as common. Again it is B plus B bar. Okay. So that is A bar C plus AC. Again I can take C as common here. It is A plus A bar. So that is equal to C. Clear?
Yes, sir.
Okay, so do one thing, we'll stop for today. So next topics we'll discuss tomorrow. So the same timing for tomorrow also. Okay, we'll stop it for today. Okay, so one thing I want to say you. So if you missed any classes, just try to listen to the recordings. Okay, and try to be updated, because you know what are the topics which we are discussing right now. So it is always dependent on the previous class. Okay, so you may feel like listening to life sciences or some other subjects. So కొన్ని subjects ఉంటాయి అన్నమాట, అంటే like cover చేసుకోవచ్చు అనే confidence తో ఉంటారు. Okay, it's not theoretical one, it's a problematic one, and each and every problem is dependent on the previous concepts only. Okay, the concepts, the subject is simple, but there are many concepts. There are many concepts, so which you have to understand and which you have to remember and which you have to implement. Okay, so that is where you can learn this subject. Okay, the consistency in listening and consistency in practicing. Clear? So we'll stop it for today, and this is the second part here. So if you have anyone has syllabus, wait, I'll check the syllabus. So R19 structure SQCT VC. 1 minute. Okay, so we are done with number systems. That is the first part, the gray codes, hexadecimal codes, and binary code classifications. So I had done all with this. So Boolean operations, so what we have seen here, Boolean functions. So algebraic manipulations in the sense all the minimizations with the help of this Boolean laws. Okay, so min terms and max terms we have seen, some of the products and product of some representations we have seen. So two input logic gates, what are the logic gates we discussed here? So NAND and NOR implementation, so I will discuss here. Okay, so in this one, so NAND and NOR implementations is an important one, but we'll discuss in the last. Okay, so we're done with this part here. So next we'll go for the next part here. So all the simplifications what we are seeing now, so they'll not follow any kind of specific method, but so we'll be going for a map method, so where the simplifications are made quite easy. So simplifications are made quite effective and quite simple, and it will follow some standard protocols. Okay, so we'll be having the map method, so where all these three comes under the map method here. Okay, so and the complex are the other functions which are complex than map methods will be solved with the help of this tabular method, or called as Quine-McCluskey method. Okay, so these two methods are the next half of the unit. So the last part of the unit will cover these two methods in major, and the NAND and NOR implementation. So we are seeing this NAND and NOR implementations here. So we can implement each and every function with the help of NAND and NOR gates. So we'll see how to implement each and every functions using NAND and NOR gates. Okay, and NAND and NOR gates are called as the universal gates. Okay, remember this. The NAND and NOR gates are called as the universal gates because so any kind of function, so any kind of circuit can be implemented with the help of NAND and NOR gates. Okay, so NAND and NOR gates can implement any kind of functions. So hence those are called as universal gates. So we'll see how to implement all those circuits what we have with the help of this NAND and NOR gates. So that will be the last topic we'll discuss in this unit. Okay, so for this K-map and all these, I'll definitely take 3 to 4 or 5 classes for memorization of this one. So for explaining one problem, we'll definitely need 2 hours for this. So this Quine-McCluskey method, for explaining one problem, for explaining one concept, it will take 2 hours. So totally we need around 10 classes for finishing this. Okay, so I'll be taking classes on Sundays also. Okay, so I need extra hours to finish off this. Okay, so totally we need around 12, the max of 10 classes to finish this remaining topics. Okay, the concepts are high, and I'll be giving more and more assignment problems, like I'll be solving more and more problems in the class itself. Okay, so that you'll understand in a better way. But most of the students, 90% of the students are not attending the classes regularly. Okay, at least try to listen to the recordings and try to make a notes of that. Okay, because you're not taking it seriously, but it'll be affected definitely. I want to say this. Okay, with this kind of ఈ ఆన్లైన్ క్లాసెస్ ఏంటంటే మీకు ఇష్టం ఉంటే వినొచ్చు, లేకపోతే లేదు. ఓకే, బట్ వినకపోతే లాస్ అయ్యేది మీరే. తర్వాత అర్థం చేసుకోవడానికి చాలా టైం పడుతుంది. ఓకే, తర్వాత రికార్డింగ్స్ విన్న అర్థం చేసుకోవడానికి చాలా టైం పడుతుంది. యూ హావ్ టు స్పెండ్ మోర్ అండ్ మోర్ టైం. I'll not say that it is not understandable when you study the textbook and all those things. The understanding is made simple when you listen to the classes. Clear?
Yes, sir.
Yes, sir.
And yeah, syllabus is compared to the last year's one. So this is lengthier one, and we add one more extra unit for this. So last unit is extra unit compared to the previous one. Okay, so we need more and more classes to solve each and every concept and each and every topics here. Okay, this is done. Boolean algebra and logic gates is done. Left with this topic here. So NAND and NOR implementations, that will be discussed last. So next we'll start with this map method here. So tomorrow we'll start with the map method. Okay, so definitely I'll be taking 2 classes definitely. Sure, tomorrow also in the morning session. Okay, and every day I'll be having 2 classes from right now. Okay, so I don't want to continue this. I don't want to skip any one of the days here. So I want the continuity to complete all these concepts, because it will be understood when you understand these concepts. When you go on a flow. Okay, so by next weekend I want to finish this half of the unit, remaining part of the unit, right? So drop your attendance. See you tomorrow.
Thank you, sir.
Thank you and have a nice day.